and welcome. In this lesson, we're going to be talking about inverse variation. But before we talk about inverse variation, we're going to go back and talk about direct variation, which you've seen before. Direct variation says if y varies directly with x, varies directly is going to be key here. Okay, with x, it can be represented by the equation y equals ax. That means when x goes up, y goes up. When x goes down in value, y goes down. We typically have the equation set up so that y equals is the form that we want to put it in. And then a, this number in front, is what we call the constant of variation. It's some non-zero number. If you think about this, this looks like an equation of a line. Y equals mx plus b. Except there is no b, or our b is a y-intercept at the origin. So this is really a linear equation. Y equals some number times x is direct variation. And you've seen that before. So for example, if we have the direct variation equation y equals 4x, the constant of variation is 4. Now let's take a look at the new part, inverse variation. When y varies inversely, now look out for these words here. Y varies inversely with x if there's some non-zero constant a such that y equals a divided by x. So in this case, our constant is being divided by x. So an example of inverse variation is x, y equals 3. This might not look like y equals ax, but if I take x, y equals 3 and I want to solve it for y, if I divide both sides by x, the x's cancel out and I get y equals 3 divided by x. So our constant of variation is the numerator right here, is that 3. And this is inverse variation. Now, how can we tell whether or not we have a direct variation, an inverse variation, or neither? Well, let's see if we can fit the two forms. Again, direct variation is y equals a times x, and inverse variation is y equals a divided by x. So when we look at this, we have y equals some number divided by x, which fits our inverse variation. In the next one, we have y equals 1/3 x. Now, you might see that it looked like division here, but it's 1/3 times. In this case, we have a, which is 1/3 times x. And when you multiply your constant by x, that is, in fact, a direct variation. Oop, eyes missing. And again, we have, next one is xy equals 8. That kind of looks like this one over here. But just to make sure, let's solve for y. So if we divide both sides by x, we get y equals 8 divided by x. And again, some number divided by x is inverse variation. And this last one here, if we want to solve for y, what we could do is we could add y and subtract 3 from both sides. Or 5x minus 3 equals y. We have 5 times x, so it looks like direct variation, except for this fact that we have this minus 3 here. Direct variation and inverse variation never have addition and subtractions of any constant numbers. We can only end up with y equals something with an x, some number multiplied or divided by an x. So this is, in fact, neither. Okay, so now let's start using inverse variation. Given y varies inversely with x, so when we see this statement right here, this is going to tell us what type of function we're going to deal with. So y varies inversely with x. Use the specified values to find the constant of variation, write the inverse variation equation that relates x and y, and find the missing values. So there are 3 things that we need to find. Keep that in mind. Always make sure you answer all things. Now, down here it says that, but when you read your directions, always make sure you underline what you're trying to find. So y varies inversely with x. Let's start off with the formula. Well, inverse variation says y equals a divided by x. That's not our inverse variation equation. This is just our formula we start with. Now let's find our constant of variation. Let's find out what A is. In order to do that, we need to plug in values. So plug in 5 for y equals A divided by 12. When y is 5, x is 12. And this is just a simple equation to solve. We multiply by 12 on both sides. 12 times 5 is 60 equals A. And there is our constant of variation. So A is 60. The inverse variation equation, there's no work to this whatsoever. The inverse variation equation is simply taking the A and plugging it back into your formula. Or y equals 60 over x. This equation allows us to solve for anything we want in this problem now. And the final thing asks, find x when y is 15. So we take our equation, but now when we have y equals 60 over x, we're going to take 15 and plug it in for y and solve for x. So first multiply by x on both sides to get it out of the denominator. 15x equals 60. Divide by 15, and x in fact equals 4. And those are 3 problems that we're going to want to solve for in these type of problems. Let's take a look at another one here. Y varies inversely as x. Let's start off again. Y equals A divided by x. The constant of variation is A, so when y is 8, x is 6. We multiply by 6 on both sides and get 48 equals A. Next, our variation equation is just simply take the A and plug it into our equation. Y equals 48 divided by x. And the final part is to find y when x is 4. So we take our equation and plug in 4 for x. So y equals 12. Now, these are algebraic problems, but they can also be used for solving word problems because there's a lot of applications of inverse and direct variation. Inverse variation, let's take a look at this one. If gas is held at a constant temperature, the pressure P varies inversely as its volume. Now let's underline that. That's important. P varies inversely as volume. So similar to when we had y and x, we start with P varies inversely is equals, and inversely means we have A divided by our other variable, which is not x in this case, it's V. So P varies inversely as the volume. And that's what we're going to start with. If the pressure is 40 pounds, if P equals 40 pounds per square inch, when the volume is 80, let's go ahead and find our constant of variation. So P is 40 equals A divided by our volume is 80. We multiply by 80 on both sides, and we get 3,200 equals A. Our constant of variation is 3,200. Just a constant, just a number. Our variation equation, what we're going to use in the next thing is P equals, A is now 3,200 divided by V. This is how the pressure and volume are related in this problem. But now it says, find the pressure when volume equals 200. So P equals 3,200 divided by our volume, or 200. Now the zeros go away, and 32 divided by 2, P equals 16. So our pressure is 16. Now, when we're dealing with word problems, we always want units. And P, let's go back. P is measured in, pressure is 40 pounds per square inch. Pounds per square inch. Okay? Oh, I forgot to write the variation equation. Or P equals 3,200 divided by v. Hopefully this helps you out with solving some of your problems. If not, speak with your teacher and they'll be able to help you out. Have a great day.